In class, this is gravitation part 3, and today we will discuss on comparison of acceleration of an object and acceleration of the earth. Now this is the earth of mass m, capital M, and this is another object of mass small m. Now according to the gravitational law, if the earth is pulling this object with the force F, then this object will also pull earth with the same force F. Now according to the Newton's second law, it says that acceleration of this object is what? Applied force on the object by the earth, that is F. This force is applied on this object by earth by the mass of the object, that is small m. So it should be equals to capital F by small m. If this object is also pulling earth with a force F, then earth will also have an acceleration, and that is what? Acceleration of the earth equals to applied force on the earth by this object divided by mass of the earth. Now what is the applied force? That is capital F, and what is the mass of the earth? That is capital M. So this is F by M. So acceleration of the earth is capital F by capital M, and acceleration of the object is capital F by small m. We will take into consideration that the acceleration of the object by acceleration of the earth, and we know that the acceleration of the object is F by small m and acceleration of the earth is capital F by capital M, and that will be equals to, if we cancel this F and F, then we will get capital M by small m. Now this is the mass of earth and this is the mass of any object. So we know that mass of earth, capital M, should be very greater than the mass of any other object. So capital M should be very greater than M. So this fraction M by M must be very greater than 1. We may say that this equation, that becoming acceleration of the object by acceleration of the earth is now capital M by small m. This must be very greater than 1. So we can say that this also, acceleration of the object by acceleration of the earth, must be very greater than 1. Let us denote the acceleration of the object as GO and acceleration of the earth as GE. So from this equation we may say that GO by GE is very greater than 1. So from this we can conclude that GO is very greater than GE. So what does it mean? That acceleration of the object is very greater than the acceleration of the earth. This reason, if this is earth and if this is any other object, so from here we can say that the acceleration of this object GO is very greater than the acceleration of earth GE. So as the acceleration is greater, so this object will fall freely on earth, but due to the mass and due to this small acceleration, earth will have almost no effect, or earth will never fall on this object. Now we will discuss on variation of acceleration due to gravity with altitude. Now let this be the earth. This is the center of the earth, that is O. We are naming it as O. Now the radius, that is the distance between the center of the earth and the surface of the earth, is R, capital R. Now an object is placed at a point P. At this point P, the object is placed and the mass of the object is small m, and the height, that is the distance between the earth's surface and the object, that is point P, the distance between the earth's surface and the point P is h. So, this object is placed at a height h from the earth's surface, and we can say that the total distance, that is the distance between the center and the point P where the mass or where the object is placed, is, say, the distance is, say, d. Acceleration on earth's surface, that is the acceleration on the surface of this earth, that is any object placed on the surface of this earth will have the acceleration, say, g, and acceleration at a height h, that is the acceleration at the point where the mass is where the object is placed, that is the acceleration at a height h from the earth's surface at the point P is, say, g dash. And one thing, that is, we can say that this distance OP, the distance OP equals to the radius of the earth and the height, that is r plus h. Now we know the relation that g equals to gm by r square. The gravitational acceleration small g equals to capital G, that is gravitational constant, the mass of the earth, by r square, that is distance square. So here we know that this and this is constant terms, these are constant terms. So g will depend on r square, and that is g is inversely proportional to r square. So we may write this. The gravitational acceleration on the earth's surface is small g, and the gravitational acceleration at this point is g dash. So for this one we may say that g dash is proportional to, because this distance r is considered from the center of the earth, and for this g dash the distance will be r plus h, that is the distance from the center to that point P, and the distance is r plus h. So g dash will be proportional to r plus h square. And for g, that is for this g, this will be proportional to 1 by r square, because the distance from the center to the surface is capital R. From this 2, if we write like this, that is g dash by g equals to, as this is inverse, so it will be, as g is in the denominator, so r square will be in the numerator, r square, and as this g dash is the numerator, so r plus h square will be in the denominator. Divide the numerator and denominator both by r square, we will get g dash by g equals to 1 by 1 plus h by r, and we can say that 1 plus h by r to the power minus 2. Now using binomial expression, we can say that first of all, this small h is very, very less than the r, that is the radius of the earth. So this height h should be very, very small than the radius of the earth. So h is very, very small than r. So this h by r, this fraction is very, very less than 1. So if we consider binomial expansion, then the higher terms are cancelled, are ignored. So using binomial expansion, we may say that we can write it like 1 minus 2h by r. From here we can say that g dash by g equals to 1 minus 2h by r, and we can write it like g dash equals to g into 1 minus 2h by capital R. So this is the relation between the gravitational acceleration on the surface of the earth and the gravitational acceleration at a height h at the point P. From this equation, we may say that if this height increases, that is, if the object is placed at a higher place than this P, then if this height increases, then this fraction 2h by r will also increase. Then this term, that is 1 minus 2h by r, will decrease. It will decrease, and if this decreases, then this equals to g dash. Then if we multiply g with this decreased term, then g dash will also decrease. So what does it mean? That if height increases, then g dash, that is the gravitational acceleration, decreases. So the gravitational acceleration g is high at the surface of the earth, and as the height increases, the gravitational acceleration will decrease, will start to decrease.